Hello? Hi. How are you?
Hello.
Hi.
Right today.
I'm doing all right. So welcome to the open source meeting. Looks like Jess and Barshan are here for now. So I guess Barshan, you want to give an update on your
Yeah,
ongoing
actually, I
things?
prepared a presentation
Okay.
to give a small, like what I did till now for the 3 months and what I'm planning to do.
All right.
So, a small presentation on that. I'll just share my screen.
All right. Go ahead.
So, is it visible?
Yes.
Okay. So, yeah. So, for this summer, my aim was to introduce attention into the Devo graph since it's mostly being used everywhere and it's very useful nowadays. So, my past recap, I've been participating in the past meetings and presented a few papers. So the papers mostly includes the Markovian worm, which is the eigen modes for the adult movement, and like dividing this worm's movement into eigen movements and then calculating the future directions using eigenvalues. Then I have cell motility, which is like I'm dividing the each cell's movement into separate eigenvalues, so I can differentiate in the movement. Like instead of taking it as a whole worm, I'm dividing the cells and then I'm calculating the demos. And after that, I started presenting on the attention base papers, which how attention has helped in neuroscience, and I've presented a few papers on that. And then finally, I have thought about introducing dynamic relation learning, which is mostly includes uh, having edges as the form of nodes and then having information on them. And then we see how it reflects on the other edges as the embryo grows or the cells grow into a full worm. And I'm planning to do a visualization in Napari, which is like a framework where we can visualize. I'll show the demo also. So these are the few demos that I've worked through over the past 3 months. So I've prepared this demos. Like this last one is basically the cell movement, which I prepared in the month of January, which was mostly about the eigen movements and the eigen and the cell movements and the motility. And the above ones is basically the movement of the cells and visualizing it in Napari. So Napari has a feature which is like heat maps. So each cell, as it grows, it will have a different importance to it, and it will define how at the end what is the cell fate of the final worm or the cell. So so I can heat map the attention or the importance of that cell and how it contributes to the final cell fate. So we can understand more where which cell is getting more importance and not. And a dataset which I've curated for using in graph neural networks, which is like a feature tensor, which is like an NPZ file, and it consists of these features. Like it has a feature tensor, which is like the number of cells, and the alive mask, which means which cell is prepared at which time. And we have the edge source and the destination, like when the edge starts and which where the edge ends. And we have the edge time and how much time the edge exists between two cells. So I'm also putting an N or the ID to the cell where we have a starting time of the edge, and we also have the total number of time steps, which is the total number of time the edge exists. And we also have the source file, which traces back to the original file from the Epic dataset. So a few goals of mine during this period, like I want to interact with the mentors and the members of the community, and also read the publications to see if any other method which is getting released or any state of the art visualization methods which are there, and also clear out every uncertainty and discuss every approach before I start with the coding period. So a few upcoming deadlines are 26 May, I think the coding period ends. July 6th is the midterm evaluation. So before the midterm evaluation, I plan to get all the attention values of every edge. And after that, I want to start with the visualization process. And by August 17th, I should be able to wrap up most of it and taking in account all the setbacks I'll be having. So I have a buffer time as well in my proposal. So I have my data set ready, which I plan to prepare, input into the model. So I have to prepare that. On the other side, I've also planned to indulge in upgrading the existing models which are in the library, indulge in the discussions and improving the usability of every. So I have prepared documentations for my data set, and also the papers that I've presented, I've also prepared a documentation. It's how I feel each paper contributes to the neuroscience or DevOps. And I'll also be uploading detailed blog posts every week at my blog post, which is Barshan is a dev. And I'll be posting my findings and achievements of my project in the Slack channels. And I'll be open to suggestions as well. And anyone can feel free to start a discussion in the GSoC open source channel. And so I am also open to any suggestions and changes, and even if they require work beyond the deadlines, any feedback is welcome from my side. So yeah, that's all.
All right, that's great. Thank you, Barshan. Yeah, so I'm glad that you're thinking about the sort of recapping what you've been doing, because you've been in DevoWorm for a while. You've been presenting on things and that sort of thing. Yeah, I remember you had that blog post on the papers. So you had or it wasn't on the papers you presented necessarily, but like the 5 papers that you found on a certain topic. I think it was attention. I'm not really sure.
Yeah, this was attention based.
So that was nice. And then putting that all together in a repo or like a place where people can access that, I think is great. We might try to repost that on the Medium blog too. So I don't know where. I guess you're posting it on like a GitHub IO type site.
Yeah, it's a personal GitHub IO site.
Okay, so we can just repost some of that content over.
I have the MD file ready, so we can just paste it in the Medium.
Okay, yeah, that's
Markdown file is ready.
Yeah. Yeah, I mean, I like the sort of the plan forward and kind of bringing attention into this. Now, of course, I don't know if you're aware we have DevoLearn, which is the software. Have you looked through that repository?
Yeah. Yes, I have.
So it
mostly includes the segmentation of the worm and other tools.
The reason I bring that up is because attention would be kind of a nice feature in there as well. Like you could use attention for both, image processing and for like networks and hyper networks and that. So I mean, our coding period is coming up at, I guess, in a couple days. So that's
like next week, or in 4 or 5 days.
Yeah. So are you ready? I assume you're ready for that.
Yes, sir.
Okay.
Actually, last week I had my final project submission at my university.
Okay.
So I wanted to wrap that up, and then I can finally put my whole time for this GSoC process.
Yeah. I mean, I think you have a pretty good handle on the scheduling on it. The pacing.
Yes.
So we'll start, and then with the coding period, we'll start doing weekly updates on like your progress that week. So we do like an update and say, this is what I've done for this week. And, it's sometimes you make a lot of progress and sometimes you make just a little bit, but just kind of unpacking what you've been doing and, what you'll be doing for the next week and all of that. That's kind of the expectation for like an update. And then we can see that happen as we go along. And if we have any problems, we can talk about them. If you run into any kind of dead ends, I don't think you will, though. It sounds like what you're doing is probably, I think it can be worked out pretty quickly. I mean,
let's see about that.
Yeah. But yeah. So and then we'll just do this week, but so we'll do it on a weekly basis. But we have, of course, a DevoWorm meeting. So if you have, we can also use that to debug problems or to go over problems or progress. Yeah, that's great. Thank you. And then, we had, I don't remember if it was Himanshu a couple years ago used Napari, or someone who used Napari to visualize, or I guess was it Napari or was it something else? Well, we've had a couple of people use a couple of different visualization methods. So tell us a little bit about Napari and how you were using it in the slides.
Okay, so I'll say it now.
Yeah.
Okay. So basically, Napari is like a library which is used for visualizing. Like we put it into like edges and we put coordinates of the cells into it, and then it has a format where we can use it. Like it has a function of heat map. So what I'm planning is every attention we have this importance, how each cell is important to the final cell fate. So I'm trying to how every division in the cell, how much is it is important to the final cell fate, that can be mapped into a heat map, which can be further visualized in the Napari. Like maybe orangish, or if it's very important, like we can select the cell fate uh, as a starters, and then for that cell fate, how each division is important will be showed in a heat map. That's what my plan is.
Okay. So Napari is like a visualization for like specialized for
Libraries.
trees and heat maps and things like that, or
Yeah, yeah.
okay. Yeah.
Tracking and heat maps.
Okay. Yeah. That's good. Thank you. Yeah, thank you, Barshan. Yeah. So yeah, we're nearing the end of our GSoC community period, and that's usually the 2 weeks at the beginning of the program. But we're talking more broadly about our community here. So our open source meetings. I'm going to go over later a few open source repositories that we have that are new, and we'll take a look at those. Um, it looks like Kewen and Utkarsh have joined us today. Thank you. I think Utkarsh messaged me about something he wanted to present.
No, I don't really have something to present.
Okay.
I was just joining to look at what was happening, and maybe I can find something to work up later.
Okay. Did you have anything you wanted to update us on, or?
Yeah, I was just working on like advanced reinforcement learning. I was like really interested in that. Yeah, so I was exploring through my own personal projects.
Okay, that sounds great. Yeah, I'd love to see some of that if when you're ready. That looks great.
Yeah, sure.
Yeah.
I'll maybe present it on next meeting. Like, I'll just get some things working and maybe make them presentable with a presentation or something.
Yeah, that would be good. Okay, thank you. Jesse, are you there?
Yes, I am.
Okay.
I had to step away for a moment. I assume we're just doing like general updates.
Yeah.
And, let's see. Nothing supremely major this week. I attended, I think it was at DevaWorm. I also attended the MIT AHA seminar series, the Human Flourishing one, which was good. That was mostly about, I'll talk more about that tomorrow, but it's basically about LM-based chatbots with different personalities. One had like dark triad like personality, and how did users work with that as a collaborator versus like the servant leader, do-gooder, more like Superman type probably.
Yeah.
So that was interesting. Just doing, I feel like I'm saying the same thing at this meeting or these meetings every week about the work that's going on in the background, but just gigantic foundational bricks being laid for a lot of JoPro stuff, and I'm very happy about it. It's the kind of work that doesn't not much you can show that's fun. I can do like a super quick. A lot of the JoPro website is coming along. Also, I mean, we'll talk about another thing, but like, congratulations on the philosophical transactions, a special issue that's coming about. That has come out, I should say, but just a lot of background movement on that front. I don't know if we're going to do any professional development type stuff today, or if you have any thoughts about that, or I forget what we talked about last week specifically. I think we're going to try to carry on some things from those discussions. But there's something particularly on my mind that I might say later or when the time comes for people, especially like software or technology centered founders or developers as you go forward, that a recurring theme that has come up again recently always comes up, but is I have a reflection to dispense at some point about that, but I'll let you choose, Bradley, kind of when and where that comes up.
All right.
On what else we want to do today.
All right. All right. Yeah, we'll come back to that. I want to do a couple of short announcements, and then we can do that. Looks like Utkarsh posted a paper in the archive, from the archive. Oh, yes, the Dragon Hatchling paper. Yeah, so
this was that inspired me a lot to start like VML things and in fact the research side.
Yeah. So that's, this paper, the Dragon Hatchling, this is the archive paper. We talked about this in one of our Saturday meetings, and I can send you the discussion that we had about it because we have it on our YouTube channel. But yeah, this was a paper where they did some reinforcement learning work, and they did like some evolutionary computation work. And it was, I can't remember, it was a very loose metaphor, but it was a very interesting paper nonetheless, and they did a lot of good work there. Did you have anything to say about it, Utkarsh, or do you have anything you wanted to kind of point out about it?
Yeah, they sponsored a hackathon in India, and I was like attending that. So the goal, like the main purpose was that they wanted to see if somebody could recreate their system. Although it was not possible during that 1 week period, I started quite late. I just tried to mimic their architecture through multi-agent system. I came in like 10th or 9th out of 2,000 people, but I had the chance to meet with their like the production head. They had like 4 people in their team at that time, including 2 researchers and 1 group director and 1 intern. So yeah, that was what inspired me to join in the like the neuro side of like research, and that's why I started like joining the development meetings and all. So I'm like still learning RL just to like see how I can advance in this, and like I just basically want to join them later on. So that can be said like it's my dream to join Pathways on their journey. So I'm just trying to read more things right now.
All right, it sounds great. Let's talk about this paper a little bit. So if we go back to the abstract here, this is a paper that kind of has a very big view of machine learning and of computing. They talk about universal reasoning models. So that's what they're trying to do here. So they introduced this concept called Dragon Hatchling, and the acronym for some reason is BDH, and I think the B stands for baby because they focus on sort of a quasi-developmental process for acquiring.
Actually, it's the model they are proposing is Dragon Hatchling. BDH is the specific product. They told us that they'll be releasing their product with the name of Baby Dragon Hatchling, which will be their own alternative to ChatGPT.
Oh, so they're forking this from a Dragon Hatchling model.
Yeah, right.
Okay. Yeah, because we weren't sure when we did the original presentation where they were getting the BDH and the Dragon Hatchling from. But so this is their approach, Baby Dragon Hatchling. And then this is, so applying this Dragon Hatchling approach to the large language model architecture that they choose here. So they have this new large language model architecture based on a scale-free biologically inspired network. So a scale-free network is the kind of network that you would find in a connectome as opposed to something you'd find in a neural network. So a scale-free network is sort of a hypothesis about how connectomes are wired together. Basically, the neurons are connected, and those connections occur at no characteristic time scale. In other words, or length scale. In other words, you have a distribution that is very broad. So any one node you sample has a wide variety of different numbers of neighbors or connections. And so this sort of scale-free architecture, if you go to the network science literature, there's a lot of sort of work that's been done over the past 30 years about different types of networks. There are these scale-free networks, which are very distinct from random networks. And the idea is that scale-free networks are non-random networks that facilitate things like information processing or, like social complexity or other things like that. You also have this type of network, which is a small world network. If you've heard of those, maybe more colloquially, that is where you have these very few nodes relative to the very few hubs relative to the rest of the nodes that serve as connectors to the rest of the network. So if you've been in our DivaWorm meetings, we've talked about the C. elegans connectome, and we've talked about the rich club neurons. And those are neurons that are very highly connected within the network, within the connectome. And those are the sort of the small world aspect of that connectome. So they don't get into small worldness here, but they do talk about scale-free networks. The reason they do that is because they want to replicate that sort of order within the connectome. So basically, they're trying to mimic transformer-like performance, but they want to use a different architecture. So it's just kind of, using transformers as the standard for performance, but using some other thing in place of a transformer. This scale-free architecture. BDH is a practical performance state-of-the-art attention-based state-space sequence learning architecture. That's a long series of words, but basically something that is amenable to a large language model. It involves sequence learning, and it needs this sort of state space aspect to it to be sort of competitive with a transformer. In addition to being a graph model, BDH admits a GPU-friendly formulation, so they can use this on a GPU. But it's also, of course, a graph model. It exhibits transformer-like scaling laws, so it behaves like a transformer if you scale up the network size. And so that's good. And then you can also represent BDH as a brain model. So the working memory of BDH during inference entirely relies on synaptic plasticity with Hebbian learning using spiking neurons. So they use a sort of spiking neuron model and Hebbian learning as sort of the basis for acquiring synaptic plasticity, or the plasticity between nodes in the connections. So that's what they're using. Spiking networks are really interesting. There's a whole conference on spiking neural networks. It's basically where you're instead of having network nodes that sort of sum up inputs or use some sort of activation function, they're actually using spikes that are very similar to what you would see in a computational neuroscience model. And in fact, if you we've been talking in DivaWorm about C302 and some of those models, those are sort of simulating the spiking aspect of neurons. And so you could build a spiking neural network from C302. Now, in C. elegans, you don't have quite the same type of action potentials you see in mammalian brains. You also have differences between development and adulthood, but you can, this area it exists, and people are trying to drive forward this idea of spiking neural networks as sort of a more biologically inspired model for modeling neuronal activity. And, the question is, can you get those spikes? And the idea is, a neuron will generate spikes as sort of like these action potential like signals, and you can take them in terms of their rate or some other type of distribution, and then you can ask, does looking at spiking or using some sort of spiking parameter perform better than some sort of activation function that you might see in a neural network? So, this is so far, I don't think it's really given a huge performance boost to models, but stay tuned for that. We confirm empirically that specific individual synapses strengthen connections whenever BDH hears or reasons about a specific concept while processing language inputs. So again, this is where you have a model that can sense things and then incorporate it into this large language model. The neuron interaction network of BDH is a graph of high modularity with a heavy-tailed degree distribution. Again, this is these statistics that we use in in network theory, network science. We characterize the graph in terms of, how many subgraphs do you have? If you have a good structuring of subgraphs, then you have high modularity. If the subgraphs overlap significantly, you have low modularity. And then this heavy-tailed degree distribution is just where you have certain nodes that are more highly connected than other nodes. Not necessarily as a small world network, but you do get that sort of hierarchical nature that emerges over time, even in these scale-free networks. So they want to look at those parameters, and they want to understand what network topology is the best for getting at sort of performance that mimics brains, or mimics maybe even just a transformer. The BDH model is biologically plausible, explaining one possible mechanisms for which human neurons can be used to achieve speech. So, this is not like mimicking exactly mechanisms for speech or for language production, but it's sort of mimicking the brain and then saying, what can we use to sort of, acquire language as a different type of model than what we usually use for large language models. So that's what they're getting at with this. So I remember that this paper was quite interesting, but it is kind of, I guess, aspirational was our conclusion. If you look at the code, and you look at the open source code on GitHub, this is, I guess, an org pathway com, and this is the BDH repository. So we have, of course, the Dragon Hatchling, the BDH. This is developed by researchers at Pathway, which is this company, this private company. BDH provides a theoretical and practical framework for understanding the emergence and generalization in artificial systems. So this is the paper that we just talked about. And so BDH represents a scale-free, locally interacting network of neurons. So this is mimicking the brain, again, capable of intrinsic reasoning dynamics. BDH scales like a transformer on performance benchmarks. It retains interpretability and theoretical grounding in the fine-grained dynamics of neuron interactions. And so they implement this using neuron particles with excitatory and inhibitory dynamics. Basically, the neurons are either excitatory or inhibitory, much like you would see in the brain. And then you have Hebbian working memory. You can implement this on a GPU. And this is the architecture here. So, it's similar to a transformer. Then you have this relation to transformers, which I think we talked about in our recap in the Saturday morning meeting, where you have tensor-based models versus local graph models for these transformers. So you have brain models here, which are like sort of purely computational neuroscience. You have the BDH model, which is like a step back from computational neuroscience towards these sort of machine learning models. Then you have BDH GPU, so then you implement BDH in a GPU, and that's a little bit closer to a more traditional transformer. So you have the theoretical formulation here and the GPU implementation here, and then of course your traditional transformer. And in all cases, you have some sort of attentional mechanism, local dynamics, and a feed-forward network. So in a brain model, you have neuron interaction graphs. And then in transformers, you have MLPs, which are defined here. The local dynamics in a transformer consist of linear algebra. In the BDH GPU implementation, you have local mean field dynamics. And then in brain models, you have spiking graph dynamics plus Hebbian learning. So they're trying to move like towards brain models, but they're trying to retain the implementation advantages of transformers. And then they show some of the scaling laws. They actually use a Sudoku benchmark, which is a research update here. So they actually have benchmarked this on Sudoku. And this is where, okay, so the repository contains the implementation of the baseline variant is described in our paper and does not reproduce the 97.4% benchmark result out of the box. So you have to play around with it to get this benchmark. They have this extreme Sudoku research blog post that kind of goes over how that was achieved. So on Sudoku Extreme, which is a specific type of Sudoku they use for their benchmark, BDH reaches 97.4% accuracy across roughly 250,000 difficult puzzles without chain of thought, solution backtracking, or external tool use. While leading large language models struggle to perform on the benchmark at all. So this is seen as sort of improving upon. We talked about large language models also in our Saturday meetings, and we talked about this sort of reasoning industry that's kind of cropped up, where you have large language models and they have outputs, and you have these models that are sort of built on top or sort of down the workflow, which is where you can get that output. You can put that into a reasoning step. So you might use a reinforcement learning model, or you might use some other sort of model to rectify the outputs of large language models to allow them to reason. So there are a lot of groups that are trying to do this, where they add in another model after, post large language model to get the models to reason better. And so this is their attempt at that sort of thing. So the repo basically has, has a license. Just went over the README. This is the PY file for the BDH. These are the requirements for training data. And then this is the train.py. And that's what we have here. So if you want to play with that, I'm not sure if that's something that's accessible, like out of the box. Sometimes you get things from repos and you have to really struggle to get them to work the way you would like them to work. But it's interesting.
Yeah, I think it is at a really early stage right now.
Yeah.
One thing that they were claiming was that unlike regular elegans, where it is hard to track what the output would be for an agent, which is why they can't use agents in like big organizations, since the output is still unreliable. They were claiming that with PDS, we'll be easily able to exactly tell what the output would be produced, since we can tell which neuron was spiking. This is the one claim that they were making.
Yeah,
that was it.
Yeah, that's I think that's going to be a real challenge for this method, is like kind of coupling the large language model reasoning with spiking outputs and all that, because it's just from my intuition doesn't mean they're going to have real problems with that, but if they can get it to work, I think it'd be pretty interesting, because a lot of the state of the art that we have for reasoning models, they can perform on benchmarks, but they're kind of restricted to the large use cases. So it'd be interesting to see how they do on this, in terms of if they can make this something that's portable, especially. So if you're like using a large language model on your local machine, or an open source model, can you use a reasoning step and you implement it pretty quickly and get it to work? All right. Thank you, Utkarsh, for bringing that up, and it's a pretty good discussion. Another thing that Utkarsh brought up in the Slack was this repository. So he's been working on this with a collaborator, and they've been talking about doing this. Who was a collaborator, Utkarsh? Do you remember?
I don't remember the name, but I believe it was French and his name. Let me just check it out here.
Yeah. So this is
John. Yeah, Jean or John. I don't know how
Jean.
to pronounce
Yeah.
it.
All right. Yeah, as someone who is interested in collaborating with the group, and so this is the C elegans circuit benchmark. So Utkarsh has been working on a number of different models. So he was presenting in the spring about using C302, which is the neuron model in OpenWorm, with like CindyG, which is a graph version of Cindy, which is a biophysical model modeling platform. And he's been doing these experiments to look and see, at the connectome to see how those models perform. So this is the C elegans circuit benchmark repo, and so this folder is an isolated reproducible package for the MDG and Kenta circuit benchmark. It packages the
MTG was the model that I was building, while Kenta was what John was working on.
Oh, okay. So you kind
we
of
wanted to see if our outputs would share some same ground.
okay. So MDG was what Utkarsh had, and Kenta was what Jean had. Okay, and then they kind of put their heads together on this. Yeah. So this package is the adult stage 8-tap withdrawal and locomotion experiment. So this is something in C elegans behavior. So you have this experiment that people do, and you can replicate it in silico, as they say. So this is a withdrawal motion. So like it's looking at C elegans movement, the movement in the adult. In a form that is easy to rerun, inspect, and port to non C302 models. So this is so Kenta is where it's kind of working with C302, the existing infrastructure, and it just interfaces with that platform. So it has a base in C302. So the benchmark hypothesis is this benchmark tests whether a model can simultaneously reproduce two things. The first is directional selectivity. So there's metric 3, which is the backward-forward ratio, should exceed 1, a value of 1, under bilateral anterior touch. So this is touching the front of the worm bilaterally, and it should move the worm either forwards or backwards, and there's this ratio you can measure during movement. And then that's directional selectivity. And then bilateral asymmetry under unilateral stimulation is the second thing it needs to reproduce, which is metric 4. And that should increase when only ALML is stimulated. ALML is a neuron in it's the ALM neuron on the left side. So when you stimulate that specific neuron, you should have an increase in bilateral asymmetry in terms of movement. So you should actually stimulate the left side, and I guess expect the left side to move in a certain. It should move in the left direction or maybe in the right direction. I can't remember. Yeah. So basically, you're doing these experiments for the connectome. You're sort of interrogating the connectome either through sort of sensory input or directly stimulating the neurons, and you expect certain behaviors. And if you can do that, then you've met the benchmark. So in C302, when this is implemented, it shows a trade-off. These signatures appear in different regimes rather than the same regime. The main scientific question is whether that trade-off is structural or model dependent. So that's what they're trying to do here. There's some, so this is Kenta. The benchmark should be interpreted. So in C302, they use things like voltage, peak voltage, voltage trace time series, etc. And then there are model agnostic terms that are sort of like what we're doing and what we expect. So you could build a non-C302 model using these parameters. And so then there's this cross-model comparison here. And then there's this formal metric contact, which is in this file compute metrics.py. So these are the formal metric definitions. So this just defines these here. So you can see they're defined, and then they're just defined mathematically here. And so this is what's there. So what's included in this repository is you have, for configs, you have benchmark config JSON. This is an experiment definition. You have SRC, C elegans circuit benchmark, which is the standalone implementation of the benchmark. You have these formal metric definitions in a Python file. You then have your run benchmark.py, so it's a Python file to just run the benchmark. You have your reference results and your artifacts, which just kind of give you the output. So you're going to get this output in JSON format, and you'll read that. And then that'll be kind of the way you can access the results of the benchmark from the model. So that's, and then, so then this is where this is, so you set up your circuit, you have data, not, you actually have data from the Whitfleet data set, which Utkarsh has been working with. That's a data set that is the larval worm. So in Daniel Whitfleet et al., they developed this data set measured from larval worms going from the L1 stage to the L4 stage. And there are these 8 different data sets. And so the stage 8 data set, I believe, is L4 or late L4 in the worm. So it's pretty close to the adult. And so the idea is everything should be pretty mature in terms of synaptic connectivity there. So you should be able to do these experiments and kind of match what's going on with C302. There are going to be some differences in how people have collected data. So in the Whitfleet data set, there's some missing neurons, but that's probably good enough, because sometimes when we have different data sets from different groups, they measure things differently. We have to account for that in our models. But anyways, so we just try to get it as close as possible. This is a results table for each metric. So you can see that for these different, P1 baseline, P2 AVAL lesion, and P3 unilateral touch, you get these different values for the different metrics. And then for P1, P2, and P3 low, which is low stimulation, you get these values. So this, and then there's some known limitations to this. The first one is that C302, of course, uses adult derived parameters, and the Whitfleet D8 data set is not quite the adult, so it might show some differences. Whitfleet D8 also measures things a little bit differently, or sums things a little bit differently in terms of the connectome. So we, again, sometimes have differences between data sets. There's this difference also in how we define a connectome, whether we use the chemical synapse data or the gap junction data, or some mixture of the two. C302 does not model neuropeptide modulation. C elegans has a neuropeptide connectome, which is available that people can use. The stimulus is artificial current injection, not mechanosensory transduction. And then the activation depth metric, or metric 2, should be interpreted with caution in graded synapse models. So this is something that I guess is intended for scientific use eventually. So that's a good good progress on that. So thanks to Utkarsh for pointing that to us. And so are you guys working on this as a long-term project, or?
Actually, I checked what John was working on. I was having some trouble understanding what exactly it was what was going on there, since the README file was in French and I couldn't really understand it. But yes, I'll be working on it further. As for the my old idea for using SynDG with the C302 results. So the problem was with Relate or the other datasets were that the dataset was too small, or for a less period of time for SynD to produce some meaningful results. So, which is why I shifted to C302 because I could get as many data points as I wanted since the simulation was running directly on my laptop. Yeah, I produced some results, but I couldn't like verify them, or there was no way that I could like prove that these equations were something that like denoted development instead of like regular mathematical equations that like shows why a neuron is changing. Like, how can I put it better?
Yeah, that's good. Well, we'll see. Maybe we can come up with some solution to that. Okay, yeah. Thank you. Yeah, Utkarsh.
Yeah, thank you. I'll make sure to present it next meeting.
Okay, yeah, be good. The other thing I wanted to point out was this. This is our new open source sustainability repo. So the old repo was, it kind of had a weird sort of intellectual lineage or open source lineage. It basically started when we wanted to have an org. I think it was in 2022. We wanted to have our own org, and we put a bunch of different projects together, and we submitted that repo, which was called GSoC, to the program as sort of our thing that we were going to work on that summer. And we didn't get the org definition, but we did continue on under INCF. So GSoC is organized by having these orgs or these organizations that apply to GSoC. And they usually have a couple of projects underneath them. And then those projects are given slots. And then so you might have an org that would include Orthogonal Lab, DevoWorm, OpenWorm, and JoPro, let's say. And then we apply to the program, which has, they might give our org 4 slots, one for each group. And so that's how it's usually allocated. So we couldn't get the org definition, but we did get we were basically a group under INCF that year, as we have been every year. So we get a certain number of slots for that group. So that didn't happen, but then we kept the projects that we were doing in 22 in that repository. We ended up having a successful first year of the open source sustainability project, and then we continued on in that same repo for until this year. And I decided that we should have a better repo for this, because we've been working on this project for a while, and there have been many different threads, and we talked about this last week. So I assembled this from a fork of the project, and then reassembled this as open source sustainability. And in assembling this, I got some really interesting insights into what we've done. So we did in the first year, we had Himanshu Shogul, who did some reinforcement learning, and we had Brian McCorkle, who did some active inference approaches to the problem. He did some nice demos of sort of social coordination. And then Hussein Ather, who's still with our group, did some things with Big Five cybernetic theory in terms of personalities and things like that. So that's all in these different topical folders. It's no longer organized by year, but it's organized by topic. So we have our reinforcement learning techniques. The following year, we had some work done, or the following 2 years, we had some work done on different reinforcement learning techniques. Actually, we had VD last year, I believe. Yeah, it was who did Sustain Hub, which was, this sort of different reinforcement learning techniques. We've done multi-agent reinforcement learning, and those are all in here. And then in 2024, we had the large language models approach, and that was Sarah Bastawala, and she's still with her org. She's doing this, she sort of pioneered this approach of large language models, and that's what we had this year as a project, but it didn't get selected for any candidates, so we couldn't get any slots for this project. But this is of course the code for this, and it's sort of now in this larger scheme of things. repo. And then, of course, we had this sustainability auditing tool, which was developed Brian McCorkle at his home university in New York State. He recruited some students for like a capstone project to develop the sustainability auditing tool. And what it is this software tool that will allow us to take data from an open source organization, plug it into the tool, and simulate some things that we might want to know about it, and have do something what they call auditing in the AI ethics literature. They call it an audit, where you can actually look at your organization and see where the flaws are, where the blind spots are, etc. So it was a real that was something that was built by these two students. There hasn't been a lot of work on it since, but we might revive it, we might modify it. But anyways, these are things that are available in this repo. So I think it's much more organized now than it was, and I think we can perhaps kind of think about it in terms of how to move forward, looking at how it's structured, just kind of from the different approaches and things like that.
Yes, and for almost everybody in here who won't have context for this, like, excellent work, Bradley. Like, as someone who's also doing this for Joe Pro and everything else, like, it's really, I'm so glad you did this, because I was trying to go back and like go through all these things, and I talked to Brian. I just looked up Brianna Adams and saw Brianna Adams.
Okay.
She's doing some really cool stuff now. She's doing stuff with like local law enforcement, and that's the trajectory that she went down. But a lot of this came through my time at UAlbany, and with like, this is, I think you said this is for like a capstone course. Like, they took the Google Summer of Code, it went into a capstone course with the like programming we tried to set up and facilitate them through that. So they used the project with a capstone course and went through this stuff. And so I've been trying to scrape together these parts too. And it's been on my list of things as I'm setting up all like the new Joe Pro website and getting this big broad history of Google Summer of Code related stuff. So this is like one of the missing pieces. And so thank you for pulling them together. And also, like, it is really, like, for everybody here, it's like, it is really cool because we don't have, it's so hard to convey the context of what's happened over the years and how it emerged. So this is a really good, having it all in one repo that way will be great. And it's just like it's a really hard thing to do what happened. Like, the work that Bradley pulled in to find this stuff and pull it and make it the way it is like really important and timely to do. So I'm very excited about that. Yes.
Yeah, and I think like because it evolves, and this happens a lot, I think, in open source projects where you go from like maybe two people sitting around collaborating, putting out code, putting it up on a GitHub repository, and then eventually maybe that turns into something like OpenWorm, because OpenWorm originated by a couple people talking about what the community needs. And so there was originally how it sort of originated was how, I think it was, it was like two or three people who were already working in like data reusability. So they were working with secondary data sets and then with C. elegans data, because the C. elegans community has a lot of secondary data. People collect data and share it. And the thought was at the time, which was back in like 2011, is wouldn't it be great if we had a resource where we took secondary data sets, we took some of these models, we tried to emulate the worm, and then have researchers come and use those things because we have that very strong community presence. And so that's what they did. And of course, this was built from sort of, in the projects in OpenWorm were built from individuals. So like there was one project, which is of course cybernetic, which was a couple of people in Siberia who were working on the biophysics of C. elegans movement. And they kind of were working on their own thing, but they brought their code into the OpenWorm organization. And so it's like, you see a lot of that sort of thing in open source organizations where people kind of contribute, but they don't contribute in the way, they have to change the marketing, or they have to change sort of the presence of it over time, because the project evolves over time. You get different ways in which you're using the code. And I think that's not really stressed as much as it should be, because I think that happens a lot. And you get a lot of chaos in like the open source space as a result. People just kind of abandon projects, or they have problems managing what they're doing and all this. So yeah, it looks like yeah. So Jess says, I've literally asked Brian in a DM this week if he still had access.
As I was going through other stuff before anything else happened, I was just like, hey Brian, like, no, this is like 3+ years ago or whatever, but like, so that was really, it's been great to like go through this stuff, and it's also like point of reference for like you all. Yeah, like this is a nice for orthogonal lab and Google Summer Code and INCF, but like keeping track. One of the incredibly increasing skills of the moment that we're in now is, how do you keep track of the things you're doing? How do you present them to other people so they can join it? And in a world of like incredibly shifting funding, how do you make things visible for people that want to give you money or support your work in some form? Like, it doesn't have to be all about, oh, I got to get the money, get the grants, but like, how do you show stuff to people? So like having this repo and doing the both the weird maintenance work and the strategic we talked about this last week, the strategy around conveying what you're working on to people matters. And it takes a certain kind of effort, it takes a certain kind of strategy, and it also like if you're interested in for lack of better more humble ways of saying, if you're interested in making serious changes in how things are done, if you want to see things grow or develop, this is sort of something that is important to be aware of. And it's, not everybody's going to be a cavalier entrepreneur, social entrepreneur, or research entrepreneur, or building all this crazy stuff. It's not really about that. I think the core thing that we'll probably talk about here, and that's essential and generally not like why many people are here today in the open source meeting is, hey, I'm interested in this space, open source opportunity to make or build to do certain things. And you probably know that in many conventional courseworks and teachings in like undergraduate and even graduate level somewhat, there isn't necessarily a focus on anything outside of that moment, that class. So how do you get involved in that community, and how do you see, the deeper you go into open source and see how open source is a bedrock for many for-profit companies too, and seeing these ways of, okay, where do these lines separate out between actual open source development, what gets shifted off to for-profit spaces, how do you understand what's going on in both of them? Like, I think there's a lot here. So, we'll come back to the moment and say, this is great for many reasons, and also because now, like when I talk to Brian or Brianna or anyone else from the open source, because I'm going through the JoPro side of things, is like, oh, like here's this great sustainability auditing tool, and our previous one of our first cohorts in the data and direction program, Arnav Satish, he did an ethical policy analyzer, which is sort of not open source code, but looking at the ESG reports and finding ways to have more transparency or standardization for some of the reporting on that kind of sustainability from a corporate documenting side of things. And it's like, oh, like there's enough here. So it's like, how do you convey what's happening in the space and giving everybody the means by which to show the efforts they're doing? And then ideally, which is sort of the key, this will never be exactly the main focus, but kind of the implicit, maybe not promise, but gesturing in open source is like, hey, other people can take this and build on it if it's useful. So how do you, if not center that, avoid pitfalls where it makes it harder to do that.
Yeah, yeah.
So it's good stuff, and thank you for putting on and recalculating, reforming this stuff, Bradley. It's good.
Yeah. So I guess we're at the top of the hour. I don't know if Jesse could, in about 10 minutes, if he could talk about the thing he was going to talk about with the professional development.
I'll tease it later because it's a broader story I'm going to say, but kind of very briefly, this is a bit more on the founder startup idea, and there are some parallels to open source proper, because the thing about open source community and sustainability, it's sort of it's this tension between the idea and the fact that somebody has to have an idea and someone has to pursue that idea. It can be a project based, it can be a component of a project, but things move forward because somebody has an idea that they have to go in a direction with. And there's no way around that. But as whatever that idea is comes in the world, things change. And if you want other people to work on the project with you, and if you want that project to have a community around it, you want to have more things in the world, all of that stuff changes and evolves. So my thing that I'll preview now and come back to later is, I think one of the most important and often underlooked things about we talk about founders, people with ideas or whatever. I do think the term visionary or even ruthless visionary, there's an important part of what that is. You have to know, you have to be willing to show up repeatedly to improve the functioning of the thing itself. Yes. But I would say what really affects the sink or swim is not how great your idea is and not how much you're willing to work on it, but also being aware of the relative strengths that you have as a visionary or a founder or a technical lead on a thing, and what do you need to do to complement that. Because I've been involved in a number of startups like UC Launch, MIT AI Venture Studios, all this stuff, and I've talked to a lot of people going through the Y Combinator and all those sorts of things, and it's I think especially for this community of very technically focused people, which is great. My advice to you, and we'll come back to this later, will be think about the things that will complement what you specialize in, and being the more honest you can be about the gaps that will fill that the gaps or the blind spots that you might have, and what you can do to intentionally deal with them as you make things and go forward. That will be in many ways what affects things getting to next levels. So I will leave it at that. There's many things implied in that, but it's to be discussed next time and going forward. So I'll keep it short-ish here. And anything else we wanted to say, Bradley, or talk about?
No, I think that's interesting what you're just talking about, though. We have to think about what, we have to kind of, when we work on a project, what are the most important things going forward? And when we talk about demos, what is the thing from the demo that's most important? So when we demo something and we do the sort of demo or die approach, we usually show off something, and we usually try to get people to understand what we're doing. And then we look for feedback that will help us improve that thing. The question is, what feedback is actually helping improve that thing? And what feedback is maybe something that is not fundamental to moving something forward? Because people can guide you in all sorts of different directions with their feedback. And sometimes if it's very vague feedback, you go off in a direction that doesn't really pan out. And so, there's a skill there that's missing, I think, in a lot of people, which is the skill of sort of taking feedback and figuring out what is the most useful feedback, what is the most actionable feedback, what is the biggest, highest payoff feedback that you can get and act upon?
Yeah, 100%. And I would say many people, like a recent example, I'm going to use the UC launch example, which was a great team that I was with. And I'm going to talk about the process as a whole rather than any specific people or whatever in it. But just the most impossible, why having good advisors is so important, and people who are willing to have real conversations with you about stuff, is because one of the hardest things to do is what Bradley just said, is like people have an expert may come to you and say, this is your problem, you need to change this. And they may be totally true. They may be incredibly right. But if you don't, and especially when you're building something, especially a brand new thing, this applies to both building a software or building a project or doing research or innovation of any kind, their advice may come from a point where they're totally true and accurate, and they're like an expert, and they might know, oh, wow, this guy who's very prestigious or really knows this stuff said this thing, and it may be true. But what you may not have context for is like, you should focus on that after C and D are done and not before A and B are done. Because if you focus on before A and B are done, and you focus on that thing that the really great advice that is decontextualized or is a missing context, or you're having another blind spot you don't see, you optimize for it, you lose your runway in the startup sense, or you lose your motivation, or you have people who are volunteering on your stuff that isn't earning money, and then they burn out and like, oh, well, we just did all this stuff, so now what, we don't need to show for it. Like, that's where this stuff really comes in, and it's really hard. So it's really difficult because you can't just like oh, I like the most omnisciently adjacent meta advisor to help me understand all this stuff. But like learning, like the deep skill of learning, how do you try to find people who have that context and can offer you like the contextualization of the feedback you're trying to get? That's oh, that's the that's the jackpot. Which you kind of just get lucky really if you can find that. But when you do, it makes all the difference because it contextualizes the important advice that you're getting. So we're gonna talk about this forever, but I think those are great nuggets to leave on to like kind of reflect over the next week and think about how does this apply to things I'm building.
Yeah. All right. Well, I think that's it for today. Unless anyone had anything else they wanted to talk about. Thank you for attending, and we'll have another open source meeting next week.
All right. Thank you, everybody.
Take care.
Bye.
Yeah.
Take care.
Take care.